Good morning, students. Today we will discuss about trigonometric functions. Before going to discuss about trigonometric functions, we should have a very clear understanding about angles. Angles are the foundations of trigonometric functions. So unless we have a very clear understanding about angle, how angle formed, its direction and its measurement, it will not be very meaningful to learn about the trigonometric functions. Okay, so before that, let's have a very clear understanding about angle and its direction and its measurement. What is an angle? An angle is the rotation of a ray with respect to an initial point. If you think about a ray, it in the form of a straight line. Okay, so let's consider this is the initial point of a ray, OA. This is along this straight line and it has been displaced or it has been rotated with respect to an initial point O, and it rotated to a point, suppose to a point B. Right? Then we say an angle has been formed. I repeat, so OA is the initial position of the ray and it has been displaced or rotated, or we can say it has been displaced by means of rotation with respect to the initial point O to another position which is OB. Then we say the angle has been formed. That line OA, so angle has been formed in which way? In this direction angle has been formed. So this side, the OA, is called the initial side. Initial side. And this side is called the terminal side. Clear? And this point is called the initial point, is also known as vertex. The vertex of the angle. And this is the angle. So we understand that what is an angle and how an angle is formed. In other way, we can say an angle has been formed when two lines actually intersect. What does it mean? If two lines doesn't intersect, then no angle is formed. Is it true? Yeah, we can say, or we can say the angle has been formed with a value 0. So that's why when there are two parallel lines, we say the angle between them is 0. Actually, literally we can say no angle has been formed. Anyway, let's come to the discussion about the the direction of an angle. When the rotation happens in counterclockwise, anti-clockwise, then we can say the angle is positive angle. If you see in this case, the displacement of that ray from the initial side OA to the terminal side OB, it happened, the displacement of OB with respect to OA happened in anti-clockwise direction. Then we can say this is a positive angle. Now suppose if the displacement happened in a clockwise direction, that means OA is the initial side and due to the rotation it has been displaced to a point called OC, where the displacement happened like this, which is the clockwise direction. Then we can say the angle is negative. Am I clear? Thank you. Now we are coming to the discussion about the measurement of angle. Like other quantities, for example weight, height, it all has measurement. Not only it has measurement in different systems. Here also in angles we can measure angle in different systems. There are two primary very popular systems by which we measure angle. These are known as the sexagesimal system, which is a degree measure, and that circular system, that is called the radian method. Okay? So the measurement of angle. So as I said, the first one is called sexagesimal system. It is known as the degree measure. And the second one is known as circular system, which is known as a radian method. Okay, all right. Now, in the sexagesimal system, that is a degree measure, we say like this: when two lines intersect, angle formed. That is a very fundamental stuff, very fundamental way of tell that angle has been formed. Now, if the two lines intersect in such a manner that all the four angles which have been formed are equal, then we can say yes, we get one of that equal as a right angle. So right angle is the unit in this degree measurement. Okay, let's understand in detail. Okay, so let me wrap this up. So what I was telling is that so we are discussing about the degree measure here. Suppose I have two lines, this line and this line. Whenever two lines intersect, these are the two lines, when they are intersect, the four angle has formed, right? Like that, this. Now, if the angles formed in such a manner that all the four angles are equal, then we can say a right angle has been formed. So we can say this is a right angle. A right angle. Right? So a right angle is the unit of this measurement. Okay? And so it is known as degree, and it has some other units. So 1 degree is also known as 60 minutes, and 1 minute is known as 60 seconds, and a right angle is actually a 90 degree. Clear? Okay. I just revisit it very quickly. When two lines intersect, okay, four angles formed. Now, if we make those two lines intersect in such a manner that all the angles are equal, then we can say one of these equal angle is called a right angle, and it is the unit of this measurement of degree measurement, which is under sexagesimal system, and that is called 90 degree. Now that can be further come down like this: 1 degree is 60 minutes and 1 minute is 60 seconds. Now let us discuss about the other system called circular system. Let's discuss circular system here. So what is the concept about the circular system? You see the wording is there: circle, circular, right? So the circular word came from the word, another word called circle. What it tells is that, suppose in a circular movement, if a point move along a circle with a distance which is equal to the radius of the circle, then we can say 1 radian of angle has been formed. Let us understand by means of pictorial diagram. Suppose this is the circle, and obviously this is the radius. Suppose O is the center of the circle and P is the initial point. So P is the initial point. Let me take some different color. P is the initial point, and that point moved along this circumference of the circle to a distance q, to a point q, such that PQ, that arc length, is equal to the radius of the circle, that is OP. That means PQ, that arc length, is equal to the radius of the circle OP. So this is the, according to the angle understanding, you can say OP is the initial site, OQ is the terminal site, and the angle has been formed like this. So this is known as 1 radian. Correct? Now, if we say this is called 1 radian, Now suppose that point P moved to another location, another point, move to another position on the circle. Suppose this is R. So then we can say this is the OR is the terminal site, and this angle has been formed. Suppose this angle is theta. So that means what I am telling, suppose the angle is denoted by this symbol is POR is equal to theta, and the arc length PR, that arc length, suppose is equal to L, and the radius of this circle OP is equal to R. Then what we can say is that L by R is equal to theta, right? The ratio of the arc length divided by the radius. So that means we can say L by R is equal to theta. Remember, here theta is measured in radian. Okay? So this implies L equal to R into theta. So this is a formula, L equal to R into theta, that will be helpful to solve some numerical problems related to angles, arc length on circles and this thing. So now we got the point about the degree measurement and the radian measurement. Now we will see the relation between the degree measurement and the radian measurement, and that relationship we'll find that relationship by means of our very fundamental understanding about the circle, its circumference, and the angle formed and all this stuff. Let's see how. Let's come from a very fundamental point, is that suppose the point P is moving along the circumference of the circle and it comes to the point P again. That means what? That means, let me draw a different circle. So, here I am giving the relation between degree and radian. A relation between degree and radian. Okay. So, this is the circle and this is the O is the center of the circle. One very fundamental point we always know that if I divide the circumference of the circle by the diameter of the circle, I get always a constant number that is called pi, which is equal to 22 by 7. Right? So what I am telling, literally I told, but in practical if you see that if the circle has radius r and its initial point is P here, and if the point P moves along the circumference of the circle and comes to the point P again, then what is the circumference? What is the arc length it has traversed? It is 2 pi r divided by the diameter of the circle. Radius of the circle is r, so diameter is 2r. So that is equal to pi, which is equal to 22 by 7. That is very fundamental things we just revisited. Now the point is, suppose the point P, when it moves along the circumference of the circle and comes to the point P again, then we see the how much radian angle it has been formed. It has been formed a radian angle of 2 pi r, that circumference, 2 pi r divided by radius, that is equal to 2 pi radian. Right? So, and 2 pi radian means the entire rotation. Now that is nothing but 4 of right angles. So that means from here it moved to this point and coming to this point. So if I draw like this, so it will be completion of this thing. So during this entire rotation, one complete rotation, how many right angle has been traversed? 4. This is one right angle, this is one right angle, this is one right angle, and this is another final right angle. So therefore 4 right angles. So we can say this 2 pi radian is nothing but equal to 4 right angles. Clear? So now, initially we discussed, right, in the sexagesimal system, that is, which is under degree measurement, a right angle is the unit, and in the circular system, which is under radian measurement, is radian is the unit. So now the relationship what we draw now is that 2 pi radian is equal to 4 right angles. So what you can say is that 4 right angles is equal to 2 pi radian. So that implies 1 right angle is equal to pi by 2 radian. Now what is 1 right angle? 1 right angle is nothing but 90 degrees. So that implies 90 degree is equal to pi by 2 radian. I hope you understood this point. So, what I will suggest you, just have a recap of degree measurement under sexagesimal system, radian measurement under circular system, followed by the relation between degree and radian as I described here. Just have a look into this for a couple of minutes, and after that we will discuss about our next topic. So this is under sexagesimal system, this is under what? Yep. So this is under, circular system, this port. Okay, and this is under the relationship between degree and radian. Please have a look into it for a couple of minutes, then we will talk to our next topic. Thank you.